When a spacecraft malfunctions millions or billions of miles from Earth, there is no astronaut to fix it, no rescue ship to launch, and no physical second chance. Every problem must be solved with lines of code sent across interplanetary space at the speed of light. In this documentary, we explore 5 legendary space missions that experienced catastrophic, mission-ending failures and the extraordinary engineering rescues that revived them. In November 2023, Voyager 1, the farthest human-made object in history, suddenly stopped sending usable scientific data. The spacecraft was 15 billion miles away in interstellar space. Its flight data system was sending a repeating, unreadable pattern of binary ones and zeros. A one-way radio transmission took over 22 hours to reach the probe. Engineers at JPL painstakingly decoded the corrupted memory and pinpointed a single failed microchip responsible for storing flight computer code. Because they could not replace the hardware, they divided the critical code into sections, modified each piece to fit into available memory elsewhere in the system, and uploaded the patch over several weeks. In May 2024, Voyager 1 resumed transmitting pristine scientific data from beyond the solar system. In April 1991, as the Galileo spacecraft headed toward Jupiter, ground controllers sent the command to unfurl its 16-foot high-gain antenna. 3 of the 18 umbrella-like rib struts jammed in place, leaving the antenna permanently stuck like a half-opened umbrella. The antenna was meant to transmit data at 134,000 bits per second. With only a tiny low-gain backup antenna capable of a mere 10 bits per second, the mission faced a 99% data loss. Engineers spent years writing revolutionary data compression software, rewriting the onboard tape recorder management system, and upgrading ground antenna arrays. When Galileo reached Jupiter, it transmitted thousands of stunning images and completed over 70% of its original scientific objectives. The Kepler Space Telescope was designed to discover Earth-sized exoplanets by staring continuously at 150,000 stars. It required 4 reaction wheels to maintain pinpoint pointing accuracy. In 2013, a second reaction wheel failed, leaving the telescope with only 2 working wheels. Without 3-axis stabilization, solar radiation pressure caused Kepler to drift endlessly. Rather than abandoning the spacecraft, engineers devised an ingenious solution. They pointed the telescope directly along its orbital plane so that photon pressure from the sun hit the solar panels symmetrically. By using sunlight itself as a virtual third reaction wheel, they stabilized Kepler and launched the K2 mission, discovering over 500 additional exoplanets. In June 1998, a series of command errors during a routine calibration caused the SOHO solar observatory to enter an uncontrollable spin. Telemetry went dead, solar panels pointed into darkness, and the spacecraft froze to -120 degrees Celsius. For 6 weeks, SOHO was completely missing in deep space. Engineers used the massive Arecibo radar dish in Puerto Rico to ping the cosmos, successfully locating the spinning observatory. As orbital motion brought the panels back toward the sun, engineers transmitted hundreds of blind recovery commands. They thawed frozen fuel lines, restored electrical power, and returned SOHO to full operation. The observatory has now discovered over 5,000 comets and remains active to this day. These 5 missions prove that the greatest tool in space exploration is human ingenuity. Hardware designed decades ago, billions of miles away in freezing vacuum, can be rewritten, repurposed, and rescued by engineers who refuse to give up. When spacecraft break, clever minds find a way to fix them. Subscribe to When Spacecraft Break for more in-depth engineering breakdowns.